Yes, I think now it is clear, no?
Yes, madam.
Yeah. So equation 3 is for the Fourier transform. Equation 4 is for the inverse of Fourier transform. Okay. So definitions only you have to just see these two definitions. You have to concentrate, and based on that we are going to solve the examples as such. Okay, where you have to find out the answer for the transform. Now, in the same way, how we can define the sine and cosine series when there is a half of the period is defined. So half of the period means of length L, or it is 0 to L, or sometimes the function is an even function, or sometimes the function is an odd function in the defined interval minus infinity to infinity. In that case, we can find out just cosine transform or the sine transform. So as an extension, we can just write down the answer for this also as a note. You can put it here. Okay, if, oh my God, power cut is there. You can hear me?
Yes, madam.
Yes, madam.
Yeah. Yes. So if fx, you can call this as number 1. If fx is even function defined, I hope even and odd function you know how to identify. Yes or no? When do you say that the function is even? Anybody? When do you say that the function is a even function? Yes, students from electronics or electrical, they know they are using many times.
When f of x is equals to f of minus x.
Yes, so if you replace x with minus x, means negative values of x, still it is giving the answer as a positive for y. That's perfectly correct. So f of minus x is equal to fx, means original function. That becomes the even function. And even function graph is always symmetrical in the about y-axis. Okay, so here like cosine function is the even function, x square is the even function. So you know the parabola graph, which is symmetrical in this part and left side part, both are same. If you take the curve like this, which are the straight lines, okay, which is also symmetrical in the in this part. So we are calculating the answer for even function Fourier transform, Fourier cosine transform. Then if it is a even function, then we can find out it's a Fourier cosine transform. And that cosine transform is nothing but fc lambda. We can write down the answer for that and just replace the function e raised to I lambda u with cosine function. And we'll be getting fc lambda, which is defined as fc lambda is equal to this is integral, sorry, 0 to infinity, then f of u cos of lambda u du. This is the definition for the cosine transform. And second one, if the function is an odd function, and that definition which sir has told me, f of minus x is equal to fx. This is the definition of the even function. Okay, and if fx is odd function, that means f of minus x will give you the negative value only, minus of f of x. Then the Fourier sine transform, then Fourier sine transform is defined as f s lambda is equal to integral 0 to infinity. This is f of u multiplied by sine lambda u du. Answer is required in the form of that. And when you take the transform, certainly there exists an inverse transform. So we can write down the inverse cosine transform and inverse sine transform. Therefore, inverse cosine transform is nothing but f, you will get the original function fx, which is by 2 upon pi integral 0 to infinity. Whatever the answer for fc lambda you got, put it here into cos lambda x d lambda. Answer is expected in the form of x. And inverse sine transform is defined again, fx is equal to 2 upon pi integral 0 to infinity fs lambda you can call, multiplied by sine lambda x into d lambda. The variables please write carefully and correctly with respect to what you are integrating and what are the limits for which variable. Everything is very, very important for calculation of the Fourier transform. So I'll just go through this note number 1, which is function is defined even function, which is symmetrical about y-axis. So left hand side y ka jo hai, positive part and negative part of x-axis will remain same. Like a parabola function, if you take x is equal y is equal to x square is your parabola opening in the upward direction. That's a cosine function, that is also even function. Okay, so you can have the even function definition with f of minus x is equal to fx, which is defined as fc lambda. And similarly, if the function is an odd function defined in minus infinity to plus infinity, odd function matlab it will be symmetrical in opposite quadrant. So like sine function, sine wave, all of you know, it is symmetrical in the first and the third quadrant. So that way we can define, like if fx is equal to x, if I take, that is your symmetrical function in first and third quadrant straight line. Okay, so this you can have the sine and cosine functions. Cosine is the even function, sine is the odd function. Sine function, you know, this graph is existing. Or if you have the straight line like this is y is equal to x, is a straight line whose answer is f of minus x is equal to minus of fx. Have you written all note number 1 and 2 and their inverses? Inverse का मतलब है where you are just putting the answer for transformed answer, put it in the integral. So go to inverse cosine transform formula, that is fx. Inverse means always fx finding and transform means always you are finding in terms of lambda. So that answer of lambda multiplied by cosine function, which is giving you the answer for the inverse fx. Similarly, sine transform, inverse sine transform is nothing but 2 upon pi integral 0 to infinity fs lambda into sine lambda x t lambda. So let us see some examples we can solve, but before that I'll give you these 2-3 results which are required for the integration. Okay, frequently used in the integral term. So we will just define those formulae and then we'll find out the answer for the transforms. Dhanashri madam and Ranjit Patil sir, please mute yourself. Ranjit Patil sir. Ranjit Patil sir, please mute yourself. Yes, so now I'll just give you the formulae based on this integration which are required. So standard formulae. So generally we need this integration formula e raised to ax sine of bx plus c or sine of bx only, which is nothing but e raised to ax upon a square plus b square multiplied by a sine bx minus b cos bx. Similarly, you just mug up this result because it is frequently required in all the Fourier transform problems. E raised to ax upon a square plus b square multiplied by a cos of bx plus b sin bx. Just remember the technique. Sine wali term ke liye it starts from sin bx and middle term is negative minus b cos bx. For cosine function, it starts from cosine function a cos bx and middle term is positive b sin bx as such. Then integration by parts formula is many times required. So integration by parts procedure, that is u v dx is equal to first function u into integral of v dx minus under the integral sign this v dx term multiplied by differentiation of u with respect to x. And choice of u or v is up to this LIATE will give you the choice of u and v. Which should be first function and which is the second function? L means log, I means inverse, A is algebraic, T is trigonometric, E is exponential. So whichever the combination present, accordingly you are getting this integration by parts rule. Okay. Or generalized rule can be used when the function is multiplied with algebraic function. So generalized rule of integration by parts can be taken it as u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and etc. So alternately positive and the negative sign. Dashes means derivatives. These are the derivatives of u, and suffixes v1 v2 etc. are the integrals of v. This can be understood for the integration by parts procedure. So many times this is also used in the integral results, and this direct result we are using. So fourth formula as such we can write down. This is from the differentiation under integral sign calculation, but we are using directly in the answers of the Fourier series. Integral 0 to infinity, definite integral sine of ax upon x dx is giving you the value as pi by 2, and one more answer is minus pi by 2 if a is positive, if a is negative. If a is negative, you can directly use this answer for the integration by parts procedure. And this complex number to already we have used in the Z transform also. So e raised to ix, whenever you get, you can just write cos x plus I sin x. If you get e raised to minus ix, you can write cos x minus I sin x, and can be simplified. Similarly, this is in the calculations, these terms may come. That is called as a gamma and beta function. So beta and gamma, these are the standard functions in the integral, which are defined with this improper integral. But of course, we are not going deep into that. Only the formula where the integral is of that category exists. Then we can write down the answer for that. So beta of mn is equal to gamma of m gamma n upon gamma m plus n. That's the result for beta and gamma relation. This is a gamma notation. Okay, beta and gamma functions relation. And formula for this gamma of n plus 1 is n into gamma n or this is also written as n factorial if n is the integer, positive integer. Okay, and gamma half is equal to root pi. That result is also used frequently in the differentiation under integral sign. Okay, and this property of the definite integral already you know. Integral minus infinity to infinity fx dx. Answer is 0 if fx is odd function. And the answer is 2 times integral 0 to infinity f of x dx if fx is the even function. Okay, so just get these results. Of course, not necessary that all will be required, but whenever while solving the examples of the Fourier transform, if we need, we can take the help of these standard forms to find out the answer for this one. Okay, so just as a simplification, take down this one. Find Fourier transform of, I'll take the example of Fourier transform, then we'll take the example of Fourier cosine and sine transform, and inverses are included in that only. Okay. So just as a
Madam, please show 8 formula, 8, 9, last one.
yes. Eighth is a definite integral property, and seventh is a gamma function, gamma n plus 1.
Thank you, madam.
Yes. So just take down this as an example. Find Fourier cosine transform of, find Fourier cosine transform of fx is equal to e raised to minus x plus e raised to minus 2x. X is greater than 0. X is of course greater than 0. Find the Fourier cosine transform of fx, which is given by these two functions, e raised to minus x plus e raised to minus 2x. So take the definition of the Fourier cosine transform, which is written in number 3, equation number 3. I'll just recollect that. See, Fourier cosine transform you have written, Fourier transform you have written it in the equation number 3. Then Fourier cosine transform is written here. 0 to infinity f of u cos lambda u du. Okay, so fc lambda is to be identified. So write first of all the formula for the cosine transform. Since Fourier cosine transform fc lambda is equal to integral 0 to infinity f of u cos of lambda u du. Cos of lambda u du. Okay. Now what is f of u here? F of x is given. So can you tell me f of u?
E of minus u plus e of minus 2u.
Yes. So e raised to minus u plus e raised to minus 2u. This is f of u into cos of lambda u du. Now anyway, there are two terms, exponential term. You can separate them and plus sign is there in between. So you can separate two integrals. So e raised to minus u cos lambda u plus 0 to infinity e raised to minus 2u cos lambda u du. Okay. And now which formula you will use? So just refer to the first result, second result, cosine function e raised to ax cos of bx wala formula. Okay, only you have to identify what is a and b. So using formula 2, using formula 2. Integral e raised to ax cos of bx dx, that is e raised to ax upon a square plus b square into cos of a cos bx plus b sin bx. This is your result. So what is a in the first integral? What is a and what is b?
A is -1,
Hmm.
B
And
is lambda.
b is equal to lambda.
Lambda.
That's correct. Similarly, second integral में a is -2 and b is lambda again. So only replace them in the formula. Therefore, this becomes first integral answer is e raised to minus u into minus cos of lambda u, correct? Cos of lambda u plus b means lambda, lambda sin lambda u, and divided by a square plus b square. So that is 1 plus lambda square. And since it is a definite integral, we have to put the limits. Limits are 0 to infinity. Wherever there is u, you have to put the limit. Upper limit infinity, lower limit is 0. This is the first integral answer. Plus, second integral answer mein a is -2, b is lambda. So use that. So e raised to -2u upon -2 square is 4 lambda square into -2 cos lambda u plus lambda sin lambda u in the limits 0 to infinity for this also. Okay. And one more thing before simplification, this should be known. E raised to minus infinity is always a 0. So upper limit answers for both are 0. No need to put in the inner term. Just e raised to minus infinity means e raised to minus t, as t is tending to infinity is giving you the answer as 0. Only lower limit simplification will be there. So both terms, upper limit answer is 0. Minus lower limit ke liye we are using minus sign. Now you put u is equal to 0. So you will be getting e raised to 0 means 1. 1 upon 1 plus lambda square. What is cos 0? What is
1.
1? So inside bracket we are getting -1. Sin 0 is 0. This is the first term. Plus second term answer. Again, upper limit answer is 0. Minus lower limit you are putting u is equal to 0. So that is e raised to 0 is 1 upon 4 plus lambda square into, once again cos 0 is 1. So -2 plus this is 0. Sin 0 is 0. So only this much is remaining. That means 1 upon 1 plus lambda square plus 2 upon 4 plus lambda square is remaining. Correct? And which is certainly the answer in terms of lambda. If you want, you can simplify further and calculate by taking the LCM is this one. So 4 plus lambda square plus 2 into bracket 1 plus lambda square upon 1 plus lambda square into 4 plus lambda square. So this is the answer for Fourier cosine transform. Correct? 4 plus 2 is 6 plus 3 lambda square upon 1 plus lambda square into 4 plus lambda square. This is the Fourier cosine transform of the given function. Any doubt? Yes, any difficulty not followed or any step where you need to calculate once again?
Madam, please explain that second last step. This one, 0 minus
Substituting
0 minus.
limits.
Ha.
See, the upper limit is infinity, for which e raised to minus infinity in both it will come. Correct? So e raised to minus infinity answer you have to put it as a 0. That means first term vanishes in both the
Hmm.
terms. And second term means lower limit answer के लिए we are writing negative sign. Lower limit is 0. E raised to 0 is 1 upon 1 plus lambda square. And inside the bracket cos of lambda u. So cos 0, that means 1. So with negative sign. Sin 0 is a 0. Correct? And second term same way. Again cosine 0 is 1. So we'll get minus 2. And sine 0 is 0. So here this is. Just putting the limits. Nothing different. Okay, got it?
Yes, ma'am.
Yeah. So one more we'll take it. In which inverse is also directly combined and getting the result. Take down this one. Find Fourier sine and cosine transform of. Next example. Find Fourier sine and cosine transform of fx is equal to e raised to minus x, and hence show that integral 0 to infinity cos mx upon 1 plus x square dx is equal to pi by 2 e raised to minus m, and one more integral x sine mx upon 1 plus x square dx 0 to infinity limits is equal to pi by 2 into e raised to minus m. Both the answers are same, integral answers. Okay, so find here, question is find sine and cosine transform of the function e raised to minus x. That's like your previous example. And hence show that. So whenever it is hence show that something integral answer, it means you have to consider the inverse transform of that. So let us first work out the first part where the sine and cosine transform is asked. Okay, so let the Fourier cosine transform of fx is equal to e raised to minus x is equal to fc lambda. Cosine के लिए we are writing c. So fc lambda is equal to 0 to infinity integral f of u cos of lambda u du. So here it is very simple, only one term is there, 0 to infinity e raised to minus u into cos of lambda u du. Correct? E raised to minus u cos lambda u du. And just now we have calculated in the previous example this answer. What is the answer for this one? Same result was there, no? 0 to infinity, this one. What is the answer for the first expression?
1 upon 1 plus lambda square.
Correct. So this is your fc lambda. I'm not again simplifying because it is there already in the above example. So answer is 1 upon 1 plus lambda square. Okay. So once you get the Fourier cosine transform, now let us select the inverse cosine transform. Therefore, by using inverse cosine transform formula, what is the inverse cosine transform formula? Fx is equal to 2 upon pi integral 0 to infinity. This fc lambda answer multiplied by cos lambda x d lambda. Please refer to the inverse cosine transform answer formula which is given above in the formulae for the Fourier cosine and sine transform. Okay, So here we have to put just this result, that means 2 upon pi integral 0 to infinity. FC lambda answer just now we got it as 1 upon 1 plus lambda square into cos lambda x d lambda. Correct? Now tell me what I should write for fx left side. What I should write fx left hand side, what is our fx?
E raised to minus x.
E raised to minus x. So that's the only thing which you can put it here. E raised to minus x is equal to this thing. Correct? Now see, the question is show that. Question is show that cos of mx upon 1 plus x square. This is asked. Equal to pi by 2 into e raised to minus m. So what you will do? We will just keep the integral term on one side. बाकी सारा shift कर देते हैं. So we'll just keep this term on one side. Therefore, integral 1 upon 1 or cos of lambda x upon 1 plus lambda square d lambda is equal to, tell me what I should write. Only integral I'm keeping and shift the term 2 upon pi on the other side. So what happens?
E raised to minus x into 2 upon lambda.
Into,
2 upon pi, sorry.
is it
2
2
upon
upon pi on the other
Yeah,
side?
pi by 2 year. Pi by 2
Pi.
year.
Correct. So it will be e raised to minus x into pi by 2. On the other side, it will become e raised to minus x into pi by 2. Is this the answer required, or what change still needs to be made? Answer is this. So what change we can make?
Substitute pi is equal to m.
Is it pi is equal to m? Let's see carefully.
M is equal to lambda.
Lambda equal to m.
No, just see.
1 plus x square. 1x. Lambda.
So first of all, we'll put answer we want it in the form of m, no? So let us put first of all, let x is equal to m if I put. Then what happens? Cos of lambda m upon 1 plus lambda square d lambda is equal to e raised to minus m pi by 2. Correct? E raised to minus m pi by 2 cos of lambda m upon 1 plus lambda square. So actually this is the answer, but answer is given in terms of x. So you can change lambda के बदले x लिखा तो भी चलेगा. No difficulty in calculation, because variable whichever you can use in the definite integral, then you can replace. Just to get the answer, replace lambda by x, so that it will become 0 to infinity cos of mx upon 1 plus x square dx is equal to e. Here there won't be any change because right hand side is just in the form of m and pi by 2. Getting? Following? No, this is just answer के लिए answer show कर रहे हैं, otherwise answer is over here. This is okay, but still it is required in the form of x, that variable x. So we are replacing again lambda with x. That's it. And on the similar lines, find out the sign transform. Next result.
गेलं इकडं गेलं इकडून आता इकडं आलं तिला
Similarly,
बाहेर आवडतं
consider
LIC प्रीमियम पण भरायचा आहे की माझा बरोबर
Roshna madam, please mute yourself. Ranjit Patil sir, he is not responding. Now take sine transform. What is the definition of sine transform? If s lambda is equal to integral 0 to infinity f of u into what?
Sin lambda u.
Into sine lambda u du, correct. So f of u is e raised to minus u once again. Simplify that and tell me just quickly the answer for this using the sine formula. E raised to minus u sine lambda u du. Yes, anybody got the answer? Answer means answer is actually given. Only you have to express into that form. No? Vani madam?
Solving, ma'am, solving.
Okay. Roshna madam, have you got the answer?
No, ma'am, I'm solving.
Yeah. Sachin Kadu sir.
Ma'am, is it lambda upon 1 plus lambda square?
Yes, very good. Perfectly correct. It is lambda upon 1 plus lambda square because the answer is given. No, show that. No. So show that answer means answer is available with you. Only thing is you require it into that form. Hmm? This is sine term. So use the formula. Which formula? Use the formula for e raised to ax sine bx wala. and whose answer is e raised to ax upon a square plus b square into a sin bx minus b cos bx. So in this case, you have to identify what is a and what is b. That's it. So in this expression, a is -1, b is again lambda. So we will be getting the result as e raised to minus u upon 1 plus lambda square into minus sin lambda u minus b answer is lambda cos lambda u and limits 0 to infinity for all. So put upper limit infinity. Once again, the answer is 0. So upper limit answer e raised to minus infinity, that is always tending to 0. So first answer is therefore 0 minus lower limit answer e raised to 0 is 1 upon 1 plus lambda square. Sin 0 is 0 and cos 0 is 1. So only minus lambda is remaining. That means we'll be getting final answer as lambda upon 1 plus lambda square, which is fs lambda. I hope all of you can understand just by referring to the formula and putting the limits. So this answer, now take it for the inverse sine transform to show the required result, and therefore consider inverse sine transform. That means fx, original function, fx is equal to 2 upon pi integral 0 to infinity. This fs lambda, you have to put it here, multiplied by sine lambda x d lambda. Please write correctly variables. Now your integration is with respect to lambda because you want the answer in terms of x after putting the limits and all. So this is therefore fx. Now what is fx? Fx is nothing but e raised to minus x, which is given to you. Okay, so fx is equal to, that means e raised to minus x is equal to 2 upon pi integral 0 to infinity. Answer of fs lambda you got just now, that is lambda upon 1 plus lambda square multiplied by sine lambda x t lambda. Now see which result we want accordingly. Other terms you can shift it. So here it is asked to show that, show that this result, x sin mx upon 1 plus x square. So pehle shift all the constant term on the other side, only integral keep it on the left side, and therefore integral 0 to infinity lambda sin lambda x upon 1 plus lambda square d lambda is nothing but pi by 2 into e raised to minus x. And first of all, you put answer we want in terms of m. So put x is equal to m. Pehle. And then again replace lambda is equal to x. So lambda sin lambda m upon 1 plus lambda square d lambda is equal to pi by 2 into e raised to minus m. And again put lambda is equal to x. So that we'll be getting lambda x sin mx upon 1 plus x square dx is equal to pi by 2 into e raised to minus m. That is remaining as it is. Pi by 2 into e raised to minus m. Following? Yes or no?
Hello. f of x is equal to e raised to minus x का घेतला?
Given, no? That is our function. This is your function. Asked to find sine cosine transform. So that we calculated and we got the answer in terms of lambda. But to get the inverse cosine or inverse sine transform, we need to substitute the answer for fc lambda and fs lambda, so that original function will come. Original function is already given, that is e raised to minus x.
Yes, yes, ma'am.
Got it, no?
Yes.
Number will do for the Fourier transform. Question is find Fourier transform of. I'm not asking sine or cosine, only Fourier transform of fx is equal to 1 and equal to 0 for mod x less than a, and this is mod x greater than a. Second term is mod x greater than a. Find the Fourier transform of this function fx. Now it is actually a discontinuous function. It is discontinuous at the point A. And mod x meaning all of you can understand. Modulus means absolute value. So actually it is nothing but fx is defined for minus a to plus a. That is mod x, which is 1. And this is the, if you see the graph of this function, then it will be like this. At the point A, there is a discontinuity, but for minus A to plus A, it is existing. Okay, and that answer is here 1. This is x, y, this is minus A and plus A. Minus A, you can have this one. Okay, answer is 1 for this. So for all, you are going to get like this. This is 1. And where we are finding out the transformed answer. Okay, so let us see how it will give you the transform. So let the Fourier transform of fx by definition. Formula क्या है Fourier transform का? F lambda is equal to integral minus infinity to plus infinity f of u into e raised to minus I lambda u du. Please write correctly. It is I lambda u. I is a complex number. I minus I lambda u du. So in this case, now you have to split the interval into 3 parts. So this is minus infinity to plus infinity can be written as minus infinity to minus a, then minus a to plus a, and then a to infinity. Actually, it is like this. 3 parts may interval is divided, where minus infinity to minus a there is no function, because the function is defined only for minus a to a. This means that minus a is less than x is less than a. So only in the middle term, the middle path, the function is defined. So in the left side part it is 0, right side part it is 0, only for minus a to a. And that you can put it minus a to a, the answer for the function is 1. So put it f of u is equal to 1 into e raised to minus I lambda u du. And it is a simple integration for the exponential term. What is e raised to ax integration? What is the integration of e raised to x?
E raised to x.
It is e raised to x only. The same thing here, e raised to I lambda u means e raised to minus I lambda u upon whatever the u coefficient multiplied, that is to be divided. So upon minus I lambda in the limits minus a to plus a. And if you put the limits, upper limit is a, lower limit is minus a. So what you are going to get? Minus I lambda a upon minus I lambda minus, if you put lower limit, e raised to I lambda a, correct? Upon minus I lambda. That means, sorry, minus I lambda. That means I can get e raised to I lambda a minus e raised to minus I lambda a upon I lambda. Am I right? F lambda is equal to. I have written the first term positive, this one. Following or not?
Yes, ma'am.
And in the Z transform already we are using and we have used this is sine cosine function in the exponential form. If anybody remembers, what is sine x? Do you remember this form? Sine x is e raised to ix minus e raised to minus ix divided by 2i. So how can I write this f lambda into sine function form? Can I write like this? Just think over how can we write in the sine form? No, sine x is this. So just compare the result. How we can write this one? E raised to I theta minus e raised to minus I theta is a sine theta. So this is and upon
Sin
2i.
lambda.
Yes, so I should get it as 2 sine lambda a upon lambda. So this lambda is remaining and 2 will come in the numerator. It's correct now? Following 2 sine lambda a upon lambda. And certainly in that case lambda should not be 0. So this will be the expression for f of lambda. Okay. And in the limiting form, if lambda tending to 0, what will be the answer for this? Just to understand, it's not required. In the limiting form, means limit of lambda tending to 0, 2 sine lambda a upon lambda. What answer I can write down for this? Do you know this property? Sine theta upon theta. What is this answer? Limiting form of this? Don't know. Sine theta upon theta in the limiting form theta tending to 0 is always 1. So here also 2 sine lambda a is there. So lambda a is there means I should multiply by a in the denominator means in the numerator also to make the equation same. And then I'll get the answer for this term as 1. So I'll get the final answer as 2a. Okay, f lambda answer is 2a when lambda is tending to 0 in this case. Lambda is tending to 0. I'll be getting the answer as equal to 2a. Okay. And this is a sine graph which is to be calculated. 2a. 2a means, so suppose the graph is required for a is equal to say 3. Therefore, for a is equal to 3, the graph of fx and f lambda can be expressed as this is your graph of fx function. So if a is equal to 3, this is 2 into 3, that is 6, it becomes f lambda is equal to 6. Okay, and you will be getting answer for minus 3 to plus 3. This is minus a to plus a means minus 3 to plus 3. So you will be having here minus 3, this is plus 3, and then you will be getting this as a step. This is the graph of fx. This is 1, 2, 3 on the y-axis. Here it is minus 1, minus 2, minus 3, and 1, 2, and 3. This is, and which converts into f lambda. This is fx. This will be f lambda graph for a is equal to 3. For a is equal to 3 means f lambda is equal to 6 we are getting. And that is in the sine curve. So that sine curve, sine lambda upon lambda. Okay, so this is lambda and this is f lambda. So we are going to get this as this is 0. 0, I'll call this as 2, 4, and 6. This is the sixth point on the f lambda axis. So just a sine curve जैसे होती वैसी. And same thing on the other side. So what are these points? Just identify where it is cutting the lambda axis. So it will be first is 0, then it can be pi by 3, then it can be 2 pi by 3. This is minus pi by 3, this is minus 2 pi by 3, and etc. So the transformed answer is a sine curve, sine lambda upon lambda you are getting, and the function fx is a step function. One answer for minus a to a, and answer is 0 for greater than a. So this is just to know, not necessary to draw the graph or anything. So fx function is transforming to the f lambda function with the help of this particular definition. Okay. Once again, you try to solve on your own so that you can understand better, and the formulae also will be remembered properly. Any doubt? So one more we'll calculate and then we'll stop. Find Fourier transform of fx is equal to 1 minus x square. X is equal to 1 minus x square for mod x less than or equal to 1. And another answer is 0 for mod x greater than 1. And hence evaluate. Hence, so once again, hence evaluate means inverse. 0 to infinity, x cos x minus sin x divided by x cube dx. Sorry, x cube into cos x by 2 cos x by 2 dx. Evaluate the answer for this integral. So first, let us see the first part, then we'll go to the evaluation. Okay. So as it is asked the Fourier transform of the given function. Now generally what happens, Fourier transform when it is asked, it is better to understand whether the function is even or odd. So even though it is a Fourier transform asked, if you can identify the function is even, your calculation task somewhat reduces. Okay, if it is a cosine or the sine transform result. Otherwise, we have to go like Fourier transform definition. So in this case, let us first find out the Fourier transform, whether it is a function is an even function or the odd function. Okay, so given function fx is 1 minus x square in mod x less than or equal to 1 means minus 1 less than or equal to x less than or equal to 1. And another value is 0, that is for mod x greater than 1. So it doesn't matter whatever it where it is 0, which implies f of minus x. If I put x is equal to minus x, it is going to give me the same answer. Correct or not? If I put x is equal to minus x, I'm going to get the same answer, 1 minus x square. Yes or no?
Yes, ma'am.
Which
Yes, madam.
implies that means your function fx, and same thing, minus 1 less than x less than equal to 1. So it is remaining same. and therefore it is an even function. When f of minus x is f of x, that means it is the even function in the interval minus infinity to plus infinity. And therefore we will use the cosine transform. Therefore, using cosine transform, f c lambda, just find out, for which is the integral formula is 0 to infinity f of u cos of lambda u du. That means 0 to infinity. Now f of u, that you have to split it, okay, because your interval is 0 to 1 and then 1 to infinity. So after 1, the answer is a 0. So you can write down this 0 to 1 plus 1 to infinity, and 1 to infinity answer is 0. 0 to 1 answer is 1 minus u square into cos lambda u du. Only that much is to be simplified. So we have to find out 1 minus u square cos lambda u du integral. Which method you will apply here for integration? Which method can we go? By parts method. Okay. So using integration by parts. This one uv dx formula we have written same, and you can use the generalized formula. Generalized formula is u into v1 minus u dash v2 plus u double dash v3 and etc. That formula you can use. Only thing is, tell me which is your u function and which is your v function in this case. Always the algebraic function first function.
1 minus u.
Yes. Yes, anybody want to ask anything? So first function is 1 minus u square, second function is cos lambda u. So this is like your u and this is like your v. Correct? So apply this generalized result. I'm audible, no?
Yes, ma'am.
First function, integral of the second function. So v is cos lambda u. So what is v1? Cosine का integration क्या है? What is cos integration? Forgotten. Integration is with respect to u. So cos का integration sin lambda u upon lambda. Lambda is a constant. So this is your answer for v1. And v2. v2 means v1 whatever you got, you again integrate. Sin lambda u upon lambda integration. So in that case, lambda is constant. Sin integration is minus cos lambda u, and once again denominator will come lambda. So this is minus cos lambda u upon lambda square. This is v2. Okay. Now we want u dash, u double dash. Now since u is equal to 1 minus u square, this first function. Okay. Therefore, u dash is equal to first derivative will be minus 2u. Second derivative will be minus 2. And after that, the answers are 0. U triple dash answer is 0 and etc. So, while doing the integration by parts procedure, our expression will be u into v1 minus u dash v2 and plus u double dash v3. Correct? So we want 3 terms plus u double dash v3. After that, the terms are vanishing because u triple dash is 0. So write down here. Therefore, this is u means 1 minus u square. V1 is what? Sine lambda u upon lambda. I'm putting brackets specifically so that you can understand what is V1, what is U, what is V2, what is U dash. Minus U dash is minus 2U. And V2, what is V2? V2 is minus cos lambda U upon lambda square. Next term is plus U double dash, second derivative is minus 2. And third derivative, we have not calculated, just take it. V3 is equal to integral of minus cos lambda u upon lambda square du. And which is nothing but minus sine lambda u upon lambda cube, because that minus sign will remain as it is. So you can put it here like that. Lambda cube, and all the terms are in the limits 0 to infinity. Correct? I'm just applying the integration by parts procedure, and just for your understanding, I have written separately what is u dash, what is u double dash, v1, v2. Otherwise, you can put it in the brackets directly if you know to calculate the derivatives and integrals. And therefore, for the now upper, not 0 to infinity, it is 0 to 1. Okay, limits are 0 to 1. I made a mistake here. This is 1. 0 to 1. Okay, now just put upper limit 1 and lower limit is 0. Can you tell me the answer for that by putting upper limit 1 and lower limit 0? Left hand side is fc lambda is equal to, if I put 1, first term to vanishing because 1 minus 1 is 0. Then 2 into cos of lambda upon lambda square. And third term minus 2 into sine lambda upon lambda cube. So these terms are remaining. That means minus minus plus, that is 2 into bracket cos lambda minus minus minus, sorry, it is coming out negative. So it is minus 2 cos lambda upon lambda square. And next term is plus 2 sine lambda upon lambda cube for upper limit. And lower limit answer, sine 0 is 0, cos 0 is 1, but that is multiplied with u, and sine 0 is 0. So all the lower limit answers are 0. So only the upper limit answer is this one. And that means 2 into bracket sine lambda, I can put it like that, 2 can be taken common, minus lambda cos lambda divided by lambda cube. Is it correct? 2 times sine lambda minus lambda cos lambda upon lambda cube, taking LCM as lambda cube. Following or not?
Yes, ma'am.
Yeah, so FC lambda answer, you just got it. Now, this is the first part over. Find the Fourier transform. So Fourier transform done. Now one more question is hence evaluate. Okay, hence evaluate the integral term. So let us first take the inverse transform of the given expression. Okay, inverse cosine term, because already we have taken the cosine transform. So take the Fourier cosine inverse transform. Therefore, now consider inverse cosine transform, and that is by definition formula is fx is equal to 2 upon pi integral 0 to infinity f c lambda answer into cos lambda u d lambda. This is actually the formula in which fc lambda we are putting. That means 2 upon pi integral 0 to infinity 2 into bracket sine lambda minus lambda cos lambda upon lambda cube into cos lambda u t lambda. Correct? This just I'm putting the value for fc lambda. So 2 you can club it on outside. So 4 upon pi I can write integral 0 to infinity sine lambda minus lambda cos lambda divided by lambda cube into cos lambda, sorry, x, not u. You can put it x because you want the answer in terms of x, no? Cos lambda x d lambda. So fx is equal to this 4 upon pi into this expression. But since what is fx? Fx we know this is a given function. What is fx given? Fx is given by this 1 minus x square and 0 for mod x less than equal to 1 and mod x greater than 1. So you can put it over here left hand side and just write down the integral term. Therefore, I can put integral term only 0 to infinity sine lambda minus lambda cos lambda upon lambda cube into cos lambda x d lambda is equal to 4 upon pi. I'm shifting on the other side, and this f of x is given by two ways, 1 minus x square, and I'll just first of all write down pi upon 4 into fx, and then I'll put the value for fx. That means pi upon 4 into this 1 minus x square for mod x is equal to 1, and the other answer is 0 for mod x greater than 1. This is the value of fx I'm writing. Fx is given like this. Okay, pi by 4 into this thing. Okay. Now, as we require the answer, accordingly, we can put the value for this x. Let's see what is the expression required. Required expression is this one, x cos x minus sin x upon x cube into cos of x by 2. Okay, but here what we got it in this case, this term we are getting lambda cos lambda sin lambda upon lambda cube. So lambda ki jagah x, if we put it, we can get the answer in terms of x. But here this is cos lambda x, it is coming. So first of all, we'll change that by taking half. Okay, so first of all, put x is equal to half, which lies between -1 and 1. Which lies between -1 and 1. This we know. And therefore, integral 0 to infinity sine lambda minus lambda cos lambda upon lambda cube into cos of lambda by 2 d lambda. Putting x is equal to half. And right hand side also you put pi by 4 into 1 minus 1 by 2 square. And another answer is 0. So this is coming out as pi by 4 into 1 minus 1 by 2 square means 1 by 4. 1 minus 1 by 4 is how much? It's coming out as 3 by 4. So that means 3 pi by 16 you are getting. Correct? Answer is 3 pi by 16 for the integral. But it is not of the same form. What we needed? The same form is needed. Integration ka variable kya hai? What is the integration variable? Variable is x, which is to be shown. So replace lastly lambda with x. So put lambda is equal to x in this last expression. I call this as I. That means 0 to infinity sin x minus x cos x upon x cube into cos of x by 2 dx is equal to 3 pi by 16. That answer we are keeping it as it is. Okay, is it what required or any still change is required here? What is asked? X cos x is the first term minus sin x upon x cube. What is our first term? Our first term is sin x minus x cos x. So you change that order. So which implies integral 0 to infinity x cos x minus sin x upon x cube into cos x by 2 dx. What do you write on the right side then? I have made the change in the left hand side, changing the terms.
Minus 3 by 16 and 3 pi by
Minus.
16.
Yes, very good. So this is minus 3 pi by 16. That's it. So that is the final value. So every time understand when the problem is given and hence something is asked, that means you are going to calculate the inverse transform of that. And in that inverse calculation, whatever the changes you need it, do it in the integral for the variable. Otherwise, nothing more a calculation as such, which we are going to do it in this case. Okay. So your homework is that whatever the examples today we have done, do it on your own by understanding. If any difficulties still arise, you can ask me anytime. Okay, because the transform definition, first of all, it is to be understood. It is not that easy, and compared to Laplace also it is difficult. So first of all, getting the definition and formula itself is a big task, understanding and remembering that thing, and then further execute the formula and then apply the formula for finding out the answers for few examples. So today we have solved 3-4 examples connecting to this sine cosine transform and the Fourier transform. Please go through that and try it on your own way, so that I'll put the second assignment consisting of Laplace and the Fourier together. Okay, not more than 10 questions, very which you can simplify within a week and submit it in the classroom. Okay, so today is my last lecture. If you have any doubts regarding the transforms, or if you still want something, some extra lecture to be taken, you can please tell me, so that after completing the next part, which will be covered by Vaishali madam. So maybe probably I'll just add her in our WhatsApp group, and she will communicate to you whether she's taking on this Saturday or from the next week. Okay, so accordingly she will convey to you that next part is the numerical methods, so that you will be learning, which is in the different form, and this Fourier transform techniques up to Fourier, Laplace and the Z transformation. So only the evaluation pattern for the examples you should know how the equations are solved. So in that case, if you have some difficulty, or if you want me to take 1 or 2 extra hours to explain this thing, you can tell me anytime. I'm ready to take, and we will clarify all the things. Okay. So just wait for a minute. I'll take your attendance. Anything you want to ask? Anybody? I hope the first assignment is submitted by all.
Yes, ma'am.
Ma'am, ma'am, I have not submitted the assignment till yet because my hand was fractured.
Yeah.
Till now, physio exercises is going on, so it will take more 5 to 7 days more for that to be healed.
Okay, I think you have sent me message, but
Yes, ma'am.
don't worry. You can upload the assignment after recovery, and for that time also is there. But at the same time, the second part also will come. So to
Yeah, ma'am. I'll do that. I'll do both of them.
yes, yes. So please see, and rest of all have submitted the assignment. So together, Vaishali madam's assignment and my assignments together will be your internal evaluation. Okay, so we'll meet again if necessary to explain this transform part. But otherwise, see the HK Das book is available online already. I have sent to you. You can refer to that. So many terms are there. So many concepts are there behind this. Even in the Fourier transform, so you can find out. But stick to the part which I have given to you. Okay, that definition, those formulae, so that it will be easy for you to refer and do it for your particular work, branch work as such. And I'll be sending, already I have sent you the recordings of the previous lectures. Today's part also I'll be sending. So please use that, refer that, and try to understand the things that is very, very important, which is required for in your future for your branch subjects as such. Okay. So shall I close the meeting if no doubts from anybody?
Ma'am,
Hmm?
yeah, ma'am, can we get the solutions to assignments once we all submit it? So that
Yes,
we
yes,
come,
yes.
we will come.
I'll send you
Yeah.
the solutions also. I'll send you through the group, WhatsApp group. Just refer,
Yeah.
connect to that and see whether your answer is correct or not. If any difficulty in
Yeah,
that
yeah.
case, I'll send you the question. So
Yes,
no
sure.
problem. No problem.
Thank you. Yeah.
Okay, okay. But try at least 1 or 2 examples daily for that, whatever the part which we have done. And especially for the Fourier transform, Laplace transform, because the integrals, you are not remembering the formulae and the basic things, if are not there, then it will be difficult to solve the examples. Correct? In that case, and everywhere, like in the mechanical system as well as in the electrical, electronics and computers, everywhere the transformation part is there where you are going to calculate it in your branch and getting the result as a another domain function. Okay, so for that also it is very much required. So don't neglect and just for the assignment's sake you don't do, but try to understand the things. Okay, see you then. If necessary, we will meet again. Otherwise, we will be communicating through our group and I will be adding Vaishali madam. She will be continuing for the next part. Okay, see you. Bye bye.
Okay, ma'am.
Thank you,
Thank
madam.